When we're talking about electricity, electricity is just a flow of electrons. And so what we have is kind of three parts to what we're doing. The first one is the current. It measures that flow of electrons, and we're going to measure that in amps. We represent that with an A. So if you had, 0.25 amps, you would write it like that. Voltage is our electric potential. If you think about potential energy, the higher up something goes, the more potential energy it has. And so when we're comparing this to voltage, the more volts it has, the more potential it has with what it's doing. And so what we have here is we have our volts, and that's measured in V. So if you had 12 volts, you would write it as 12 V. Lastly, we have resistance, and resistance will slow down the current. And it slows it down because it's using that power, the power that's coming out of the battery. The current and the voltage combined will give us our power, and that's going to be measured in ohms. Ohms is written with the Greek letter omega, and it looks like that. So let's say you had 45 ohms, you would write it something like that. So these are the three components of the electricity that we're using. The other thing that will come into play a little bit later is power. That's represented with a P. We've used power before, and we're going to measure that with our watts still. So we have watts, and that's represented with a W. And power ends up being the output of what we're doing. When we're drawing a schematic, we'll have different symbols here that end up being used in our resistor, or in our schematics. And so we have a battery. It'll be along the wire. You'll have two lines that are parallel to each other. One of them is shorter than the other. We'll have a resistor. It looks like this. It's kind of a squiggly little zigzag line. And then we'll have a bulb. The battery is what's providing our voltage, and so you'll measure that in volts. The resistor is a resistance, and so we'll measure that in ohms. A bulb is also a resistance, and so we'll also measure it in ohms. It just signifies that it's a bulb and giving off light as opposed to just any other type of resistor. And a switch isn't going to be calculated into anything. It just indicates that there's a spot in your schematic that you have a switch that you can turn things on and off, or open or closed, or however that works. Two equations that we have, both of them are pretty straightforward. V equals IR, where V is your voltage, and that's measured in volts, and that will be equal to your current, which is measured in amps. It's represented with the I there, measured in amps, and then resistance, which is measured in ohms. And so depending on what you have, we'll end up with the voltage. Sometimes you'll know the voltage and the current. You'll need to calculate the resistance, however that might work. Power is the other equation that we have. It's structured similarly, and we have power. And like we said before, power is measured in watts. We still have our current, measured in amps, and now we have our voltage, still measured in volts. So if you have two of any of these four variables, you can figure out the other two with the equations that you have. Sometimes people prefer to see these in a way that can calculate a little bit easier. If you take a circle and draw it, and you can put V and then I and R here. And some people like this, some people don't. But if you're calculating for V, you need to find V. You cover up V, and both of these are next to each other, so you would multiply I and R. Let's say you wanted to find the resistance. You'd cover up the resistance. That's what you're trying to find. And you would have V divided by I. If you're trying to find the I, the current, you'd cover that up, V divided by R. You can do this with P equals IV as well. You can put your power here. I and V, if you're solving for the power, you would cover that up and multiply I times V. Solving for voltage, you would cover that up, P divided by I, and I, you'd cover that up, P divided by V. Some people like that. Some people would prefer to just do it straight from the equation. It's up to you on what works best. If we look at sample here. It says a 9-volt battery is connected to a resistor of 60 ohms. Let's just draw that over here. We put our battery, we have our 2 lines next to each other, one's longer than the other, and we'll have a resistor of 60 ohms. And so we would just draw that in like this, where we have it, things like that. And so we would write that next to it. We would write in what we know, we have 9 volts, and we would write in what we would know of 60 ohms like that. And we want to calculate the current here. And so we would take and we would put our variables in. Variables become important here because it shows that you know the physics and what you're talking about. The 2 equations are pretty similar. And so being able to say like, oh no, I'm solving for current, or I'm solving for power or resistance or voltage, whatever it is, becomes important to show what you're talking about. So we have 9 volts for our voltage. We have our resistance of 60 ohms. And then in this case, we're solving for current. Current is represented with I. I know that makes no sense, but current's represented with I, and that's what we're going to solve for. So we have V equals IR. I'm solving for I, so I'll bring the R over by doing the opposite. Opposite of multiplying is dividing. So I'm left here with I equals V over R. I'll take the numbers that I have here. My voltage is 9 volts, and when I divide by 60 ohms, I end up with 0.15 amps is what ends up there. And so that would be solving for the current. And when we're talking about current and we're looking at it, the current is the same all the way through. So if I have 0.15 amps coming out of the battery here, 0.15 amps, and it comes here and it goes here, I've got 0.15 amps going through the resistor, and then the same amount still comes back. 0.15 amps still comes back to the battery. So it still keeps in one full circuit. If I increase the resistance, that current goes down, but it still is the same at every point in that circuit there. The next thing asks us to calculate the power. So we still have the same variables. We have V is 9 volts. We have our resistance is 60 ohms. And now we have the current. I from up above is 0.15 amps, and we'll calculate for power. Sorry, that's a question mark. So we have power equals current times our voltage. So we take our current, 0.15 amps, times our voltage of 9 volts. And when we calculate those together, we get our power is, 1.35, and it's watts. So not a lot of power coming out of this one, but that's the process that you're going through. Frequently, you'll have enough information to solve for something using one equation and then solve for something using another equation.